So if you have something different, it doesn't mean you have to frantically erase because you're wrong, it just means you did a different way. And so if you need me to check yours, I definitely can. On this one, which side would you box in?
Right.
Definitely agree. Okay, cosine of A minus B. When you see that, you know that you have a difference formula, right? So look at your formula sheet. When you have cosine A minus B, how do we break that down? And that is given on that formula sheet. The bottom we don't need to do anything to. And now we can see there's two terms on top and only one on the bottom, so we could break them up and put each one over the denominator. When we do that, what happens? Drop a cosine A, sine B there. So when I'm left, cosine B over sine B, sine A over cosine. This is the point where you do have to know a formula. When you see cosine over sine, what does that turn into? Cotangent B plus sine over cosine is tangent of A. And isn't that what we wanted? Yeah, just in a different order, but that's fine. Oh, shoot. Miles is sticking it when people are gone. Making things happen. Alright, is that one okay? So on problem 20. Which side did you box in? I definitely agree. When I look at these, what I look at right now is, oh, these are 2A's and these are just A's. As soon as you see that 2A, you need to be looking at your double angle formulas. So we have two. Cosine 2A, there are three different options for cosine 2A. You can get there from any of them, but if you think about what you want, we want cotangents and tangents. That means we want sines and cosines. So I would pick the one that is both sine and cosine. Okay, sine 2A, we have only one option, that is sum of 2's drop. And now it's kind of like the last one. We have two things subtracted on top, a single term on the bottom. So what can we do? So that means we could drop one cosine out. That would leave us with cosine over sine. This one we can drop out a sine, which leaves us with sine over cosine. Cosine over sine is sine over cosine. So look at your formulas. And then my goal, I had different things added and subtracted, so I broke that fraction apart. All right. Is that one okay? Which side did you box in? And I do agree with that. Not that it looks so much better, but you notice, again, we have this 2 theta over here. So that usually if I see one with a 2 theta, I start working with that side so I can sub in a formula. I have a tangent. Where I'm going to doesn't have tangent, so what can you change tangent to? Okay, sine 2 theta, we could do. And there is no denominator, so that one's just over 1. So then we can see, if we have a cosine on top and bottom, those cancel. So we get 2 sine squared theta. Now, you might know where to go from here, and you might not. If you don't know what to do from here, what's our strategy? Box it in, go work the other side and see if you can get there. Or you can recognize where we're going, we only want cosines. I don't want sine. What can you change sine squared to? Yeah, using your Pythagorean identity. That's 1 minus cosine squared theta. Now, if you wouldn't have seen that, you would go work the other side, and you can get there. But then, if we distribute our 2, we get 2 minus 2 cosine squared theta. If at any point on the test you get stuck on a proof, please don't erase. Box it in. Or even if you really need to, get a new sheet of paper and try reworking it. Because a lot of times, you'll get to a point and you'll realize that, oh, these match, or oh, this is what comes next. So don't just erase everything when you get stuck. Is that one okay? Which side did you box in? We've done this a lot. If we want to add or subtract, we know we need a common denominator. So I have to take this one times 1 plus cosine theta on top and bottom. And this one times 1 minus cosine on top and bottom. So when we do that, we distribute sine theta times 1 is sine theta. Plus sine theta cosine theta. What do we do on the bottom? If you FOIL those, you get 1 minus cosine squared. Minus, over here I have to distribute sine cosine. So sine theta cosine theta times 1, just sine theta cosine theta. Minus sine theta cosine theta times cosine. We FOIL the bottom, we get 1 minus cosine squared. Now, if there's a minus, what do we do? So, positive sine theta cosine theta and negative cancel. We have sine plus sine cosine squared. All right, look at our goal. Any thoughts on where we could go from here? Okay. There are 2 things. We can factor out the sine on top. So sine divided by sine is 1. Cosine squared. On the bottom, what is 1 minus cosine squared? Now, one of these signs drop. Look at your goal. You want 1 plus cosine squared, which we have, times cosecant squared. But, you may not have written this, but if you don't see it, this is the same thing as saying 1 over sine times 1 plus cosine squared. 1 over sine. And that's what we want. doing on this? Is it helping seeing those? Problem 17. So I'm assuming everybody boxed in the right. Hoping nobody tried looking left on that one. So this we use the sign, sum and difference formulas, all given to you on your formula sheet. There's a nice little section for the different ones. So that's sine of the first, cosine of the second, and remember it's not a negative theta. The negative just tells me we are using the sign difference formula. Minus cosine of the first, sine of the second. If you need to, you could think about a unit circle. If you really need one, I can give you a unit circle on the test. You're at 270. That's the point 0, negative 1. What is the sine of 270? Sine is the y on the circle. Minus, what is cosine of 270? So negative 1 times cosine is negative cosine. 0 times sine is just 0. That's gone. We've got our negative cosine too. You good with that one? Which side did you box in? Okay, box this side in. Probably. Okay. There are several different routes on this one. What did you guys do? Or what do you want to do? Sines and cosines. You can use the Pythagorean identity on this as well. If you're looking at those Pythagorean identities, those fundamental ones, we know tangent squared plus 1 is secant squared, so you could use that on your denominator. But if you don't, that's fine, just sines and cosines. Tangent, sine over cosine. Now, we have a fraction and a fraction, which we do not like. The strategy that I have given you before is to multiply by the denominator. So if I take everything times cosine squared theta, if we distribute 1 times cosine squared theta is cosine squared theta. What happens when I take that times my sine squared over cosine squared? On the bottom, 1 times cosine squared, sine squared, plus sine squared theta. Okay. Again, from here we have multiple options. Probably the easy one on the bottom, cosine squared plus sine squared is 1. On the top, you might recognize it. Cosine squared minus sine squared. That's a double angle identity. That's cosine 2 theta. And so then if you catch that, cosine 2 theta has 3 different options, right? So you might have done this, and then used another cosine double angle and turned it into 2 cosine squared theta minus 1. The other option, if you're not good at recognizing those, another route you could have taken, look at your goal. We only want sine, or we only want cosines, right? So if you want to get rid of sine squared, what is sine squared equal to? In which case then you distribute your negative. Cosine squared plus cosine squared is 2 cosine squared theta minus 1. So 2 different routes at that point. One, if you recognize the double angles. If you don't, that's okay. You can get there from your Pythagorean identity. Okay? How about 15? Thank you.
Thank you, Ms. Buckley.
You're welcome. Have a good day. All right, which side would you box in? Okay, what do you want to do? I'd definitely change the bottom, and I also heard sines and cosines. Do you want to do both? So we have 2. Tangent is sine over cosine. On the bottom we have sine 2b, which turns into 2. What happens with the 2's? Those would cancel. And so what we have is sine over cosine divided by, it's like sine cosine over 1. How do you divide fractions? When you do that, what happens? Cosine times cosine is cosine squared. So this is one of the identities you have to know. What is the reciprocal of cosine? One more proof here. What'd you box in? So again, there's options on this problem. What are your thoughts? Okay. Yeah, so I heard 3 different options and they all work. I heard separated, like if you put each one over secant, and we could start simplifying there, that would work. I heard change your sine squared into the cosines, and we could do that using our Pythagorean method. I also heard double angle, which if you recognize that, we can do that. So any of those options work. Do you guys have a preference on how I do it? Double angle? Okay, so cosine squared minus sine squared is cosine 2x. Think about our goal. We only want cosines. When you look at your double angles, there are 3 identities for cosine 2x. What's the one that only has cosines?
I think you wrote the problem down wrong.
Oh,
I
did
think
I?
just secant of x, not
Oh,
secant.
yep. Thank you. Would have caught that in a minute when the proof didn't work. What would we change cosine 2x into?
2 cosine squared x minus 1.
What can we change secant into? Okay, just like we talked about in the last one, if you want to divide by a fraction, divide by the reciprocal. So if we distribute our cosine, 2 cosine squared times cosine, 1 times cosine. Is that one okay? Alright. I think we're doing okay time-wise. You guys okay if I keep working backwards? So, this one I told you that cosine of x is radical 3 over 5. Sine x is greater than 0. And I have asked you to find sine 2x and cosine 2x. And these can be confusing, but really helpful if you just take a second and write out your formulas. Sine 2x, there is only one formula for that. It is 2 sine x cosine x. That's how we have to get it. And when I'm looking at this, I don't know sine x, and I know cosine is radical 3 over 5. What am I going to do to figure out what sine is equal to? I know sine is positive, so that's either quadrant 1 or 2. Cosine is also positive, so it's quadrant 1. Okay, I am drawing this triangle for x, and I'm using this ratio to get there. So this angle is x, so that angle is x. Cosine is adjacent over hypotenuse. So then Pythagorean theorem. A squared plus b squared equals c squared. B squared equals 22. Square root, we do plus or minus, but in the first quadrant we know it is positive. Make sure it doesn't break down. 22 can't be divided by any perfect squares, but if it were like 20, I would want you to write it as 2 radical 5. So now I have my triangle, so I can get sine. Sine is opposite over hypotenuse. Radical 22 over 5. When you multiply these, you just multiply the tops. The 2 is outside the radical, so it stays outside. 22 and 3 are both under, so we multiply those under. On the bottom, 5 times 5 is 25. So 2 radical 66 over 25. So cosine, you have 3 different formulas. You pick one. So 2, the cosine squared x means you take the cosine and square it. And when I look, cosine of x was, so radical 3 squared is 3, 5 squared is 25. You're welcome to use a calculator at this point. 6 over 25 minus 1, so we get negative 19 over 25. Yes?
In this case, would it be better if we use that one just in case we messed up with our triangle?
Yeah, it's good insurance. That way you would definitely get it right. In general, as long as your triangle is correct, it wouldn't matter which one. But I prefer to use given information anytime possible. Is that one okay? So this time I gave you cosine of 2x. I'm telling you that x is between 0 and 90. So you notice this problem. This is x, this is 2x. Okay, that tells me that my x triangle is in quadrant 1, but did I tell you what triangle or what quadrant this was in? No. Alright, I need sine and cosine of regular x. So you pick an identity to start with. Preferably not the one with both sine and cosine, but either of the other two. So I heard 2 cosine squared x minus 2. We know cosine of 2x, that whole thing is so now we solve the equation. So we add our 1, divide by 2. To get rid of a square, we square root, plus and minus, but what quadrant are we in? 1, so we know it's positive. How would we break down the square root of 8? We don't leave the square root on the bottom, so if you multiply by the square root of 2, so we get cosine to be radical 2 over 4. We have 2 options for getting sine. We could do the exact same thing using the 1 minus 2 sine squared x formula. Or we could use our triangle for x. Cosine is adjacent over hypotenuse. So a squared plus b squared equals c squared. equals 14. Square root plus or minus, how do we know which one it is? Quadrant 1, so it's positive. So sine, opposite over hypotenuse. And for 14 over 4. Absolutely. That's perfect. Other questions? So 11. I just asked you to simplify here. All I was wanting is to see if you could recognize your identity. You have cosine squared 7x minus sine squared 7x. Cosine squared minus sine squared. What's that? That's the cosine 2a formula. A is just your angle. So 2 times 7x is 14x. We don't know what x is, so we can't simplify anymore. That's our answer. So number 11. We have to use the cosine of a minus b formula. So we know that formula is cosine of the first, sine of the second, plus sine of the first, cosine of the second. And everyone knows how to read those formulas to understand what we're doing on everything? Okay. At this point, we just need to evaluate. Oh, hold on. I did the sine formula, didn't I?
Yeah.
You guys were just gonna let me write it down and go with it, weren't you? Whoops. No, I just started.
I was looking at it like,
I don't see the formula.
I was just gonna do sine for just mix it up a little bit, you know. Okay. 135. What quadrant is that in? Reference angle 180 minus 135. In quadrant 2 is cosine positive or negative. What is the cosine of 45? In quadrant 2 is sine positive or negative? Positive. What's the sine of 45? You are welcome to leave your answer there. You know, there are different things you could do. You could factor out your radical 2 over 2, but it's not required. I just said write it where x is the only argument, so it's only sine or cosine of x. I just can't answer those, so you just write it. What?
That's what I did too. I just subtracted. But they're
yeah, I did. Wrong. You don't realize that. I still got the right answer. It was these four. It's still has it right.
Okay. What was my recommendation on these?
Make it into a plus.
Okay, so yeah, so a couple things that you can do. At the very least, you need to convert it into degrees. So that's cosine of negative 105 degrees. Now there are probably 3 different options. If you remember your negative identities, cosine of negative 105 is the same as cosine of positive 105. But I'm not giving you those on the test, and we don't really have to have them. You could find 2 angles that add or subtract to negative 105. Or, if you prefer to live in the positive world, you could add 360 and deal with a positive. What did you guys do? We are positive people. Or you could have added 2 pi at the beginning and then converted.
Oh, I didn't
Yes.
add 2 pi, I added.
You Oh.
Okay. So I need from my unit circle. You are welcome to a blank unit circle if it helps you on your test. 2 angles that would add or subtract to 255.
225 and 32.
Okay. So on your flip chart, you are looking at your cosine of A plus B formula. So it's cosine first, cosine of the second, minus sine of the first, sine of the second. Okay, what quadrant is 225? Reference angle.
45.
So in quadrant 3, is cosine positive or negative? And what's cosine of 45? Alright, cosine of 30.
Yeah, I didn't.
Your final answer will turn out to be the same. But. Okay, in quadrant 3, is sine positive or negative? And what's the sine of 45? And the sine of 30? So if we multiply, we get negative radical 6 over 4 minus a negative, so plus radical 2 over 4. You might have also had it, depending on what you picked, like this. That's equivalent. You can make one big fraction. Lots of options.
He used 5. He added the 5.
I messed it up by
Instead of like adding 2 pi or something or changing,
Right
he
here,
added
change.
5.
Yeah, because I noticed that.
Yeah, so.
No, he said it like, no, I didn't
I'm-
know.
No, I didn't.
I don't know. You need to separate them every day.
I wasn't thinking you just get. I knew there was a 3 to 4 and do that.
Uh-huh.
So I just did that.
It's impressive. All right. C.
I don't have
All right. Does this look familiar?
Yeah.
Sine cosine plus cosine sine. What formula is that?
Sine plus whatever there. Yep.
31 plus 59 is 90. What is the sine of 90? Huh? What term?
I had to like.
Yeah, need a second. Yep. Are you?
Yeah, her brain was still loading.
It's okay. I have those moments more often in your class than any other, just because it's the last hour of the day. Tired. All right. What do we do on this one?
Multiply by 180 over pi.
Right. Let's convert it into degrees. So if you multiply by 180 over pi, this is the tangent of 15 degrees. All right. Give me nothing that adds, but what would subtract 15?
45 minus.
Okay, I heard 60 minus 45 first, but you could also do 45 minus 30. So, you are looking at your flip chart, or when you have your test tomorrow, the formula sheet, sum and difference, tangent of A minus B. So, tangent of A minus tangent of B over 1 plus tangent of A, tangent of B. What? Remember tangent. Square root of the top over square root of the bottom. So the tangent of 60 would be? Yep, radical 3 over radical 1 is radical 3. Tangent of 45, radical 2 over radical 2. 1 plus tangent of 60 times the tangent of 45. So radical 3 minus 1 over 1 plus radical 3. Now, tangent is the weird one. Because I've talked about, I'm going to let you leave it like that, but if you use 30 and 45, yours looks different right now. So you might have had 1 minus radical 3 over,
One minus radical 3 over 3.
yeah.
Divided by 1 plus radical 3 over 3.
So if you had done the 30, you probably got to the point where you had 1 minus radical 3 over 3 and radical 3 over 3 plus 3, right?
Plus 1.
Plus 1, sorry. At this point though, do I let you leave it with a fraction and a fraction? No. So what I had you do is just take everything times 3. So you would have 3 minus the square root of 3 over 3 radical 3 plus 3. So that is an equivalent answer. There are some others, depending, so if you need me to check yours, I can. If we all rationalized and got the radical out of the denominator, all of our answers would look the same. But this is acceptable here. Alright, think we can get through our last few?
Yeah.
Are you guys okay on the rest of them? Bus riders are okay? You good on the rest?
One minus sin squared.
What's wrong?
Oh, I'm trying to check my answer.
Oh, yeah.
But I
Use of all the grandma.
I did these before. I said that it.
Oh.
Oh, because you didn't have
I didn't make it up. Reassurance.
Alright, what adds or subtracts to 165?
120 and 45.
Yep, you could do 135 plus 30, that also works. Alright, are you guys with me for the last few problems here? Okay, so sine of A plus B is sine of the first, cosine of the second, cosine of the first, sine of the second. Please don't skip the step where you write that out, because it's kind of hard for me to follow if I don't know what you're doing here. What quadrant is 120 in? Reference angle?
60.
Okay. In quadrant 2, is sine positive or negative? And the sine of 60? You did cosine. I was asking for sine. Cosine of 45?
Radical 2 over 2.
Okay. In quadrant 2, is cosine positive or negative? Cosine of 60?
1.
And sine of 45?
It's radical 2 over 2.
So we get radical 6 over 4 minus radical 2 over 4. Is that good? Alright, we are almost there. Problem 8 was a little bit tricky, mainly because people got the answer and thought they were wrong. So I told you to write it in terms of sine and cosine. What is cosecant?
1 over
What is secant?
What is it?
If you are going to add or subtract fractions, what do you need?
Common base.
Alright, so I'm going to multiply this one by cosine squared on top and bottom. And this one by sine squared. So we have a common denominator, we can put them together. What's cosine squared theta plus sine squared theta?
1.
You might have seen it from here. If you didn't, you could always separate It's the same thing as saying 1 over sine squared times 1 over cosine squared. So these are the ones you have to know. What's the reciprocal of sine? And the reciprocal of cosine? So, seems kind of weird, but cosecant squared plus secant squared is equivalent to cosecant squared times. All right. Problem 7. And there's 3 different options. Sines and cosines is probably where you started because that's what I told you to. Yeah, you might have started with the Pythagorean identity, that's also okay. So lots of different options. If you just did sines and cosines, since that's what I heard first. When you multiply these, get sine squared theta over cosine squared theta. When you multiply these, what happens? Everything cancels and leaves me with 1. So I have tangent squared theta plus 1, which is you could have also done 1 plus cotangent squared, that Pythagorean identity to start with. You could have changed cotangent to 1 over tangent squared and worked from there. So several options. Alright. Are those okay? Alright, so the first 6. Mostly just recognizing identities, but a couple that you had to think about a little bit more. Problem 1, this is something we have used a lot. Cosine squared is equal to, that's our Pythagorean identity, we use it all the time. Number 2, 1 over cosecant. What is the reciprocal of cosecant? Number 3, what is cosine over sine? Number 4, what is cosine of a negative? Remember, cosine and secant are the only 2 like that. The other 4, the negative comes out in front. We saw that when we were graphing. Okay, cosecant squared x minus 1. So if you're looking at your identities and manipulating those Pythagorean identities, this is equal to? And number 6 you had to think about. What is tangent? And to divide fractions, which gives us? Alright. We got through the whole thing. That's impressive.